Hello, good evening, guys. So this is Dr. Pooja, and I welcome you here to my another session on, excuse me, understanding, type of bonding. Okay, so here we will talk about different type of chemical bonds that we have among different elements. Let me see why it is not streaming. Give me a second. Give me a second, guys. Yes. So yes, as I said, here we will talk about different kind of chemical bonds that we see in different compounds around. Compounds around us. I'm sorry about this. Um, I got this live streaming on my phone. So guys, yes. So we will talk about understanding the different. Hold on. Yes. So we will talk about understanding the type of chemical bonding among different chemical compounds. Okay, so that is the topic for today's discussion. I know people are joining in. Richa Haldi just joined, and Aksar Jariwala. Hello guys, hello, welcome to the session. And yes, hi from my side. And this lecture today is going to be very informative when it comes to what kind of different chemical bonding we see in the compounds around us, okay, in the science around us. Saksham, hello. So let's get started, and before I get into the details, hello, Akanksha, just a second. So as I am moving forward, so let's see. So that is the topic of today's discussion, and I forgot to mention my code, which is PS1. Start learning from your educator. Okay. So here I am. My name is Dr. Pooja, and I have done PhD in biotechnology, and I have 8 years of experience as a scientist in United States of America. So by any chance, if you want to learn more about how to become a scientist or how to choose science as a subject or as a career, you are more than welcome to come and join my Telegram group, because I talk a lot about these kind of non-conventional topics which are going to really help you in your career. And now I am an online fitness coach, and I'm a science educator on Unacademy. Guys, for your information, I teach physics, chemistry, and biology, and on Unacademy. So we are currently doing chemistry. Okay, if you are part of the batch courses, and I'm almost done with the chemistry part. This topic is not from any chapter, Saksham, because see, I have seen many of you guys, you don't have the understanding of kind of bonding that we see among the chemical compounds. So I just picked this random topic so that you understand how the chemical bonds are formed, how different molecules and different compounds that we see around us, how they are formed. So that is why I mean, it is not that is my habit actually. I just pick topics which are very important, not maybe now but later, when you go to the higher classes. Okay, so as I said, I teach you guys physics, chemistry, and biology on Unacademy's platform. And these days, in the month of August, we finished our chemistry, and there is one more chapter left, which we'll be doing next week: periodic table, periodic classification of elements. And now in the month of September, we will be doing biology. So if you guys feel a need of learning from an experienced educator like me, who has done PhD in biotechnology itself, you are more than welcome to join Unacademy's team. Okay, but how to do it? This is Unacademy subscription. Why to take Unacademy subscription? Let me tell you real quick, because you don't have to go anywhere. You will be learning from your home. I will be teaching from my office. So it is going to be a really win-win situation for both of us. You have unlimited access to the courses, because all the course material is handmade by us, okay, by all the top educators from all over India. Hello Arhan, Yash, Ankita, Nancy, it's me, Akanksha, Saksham, Akzar, Richa. Be there, guys, because today's session is going to be super important. It's going to be super informative. I am going to draw everything for you guys in this presentation, so that you can learn like how do we write the electronic configuration, how do elements they come together to make different kind of bonds, what are ionic bonds, covalent bonds, van der Waals forces, what are hydrogen bonds. So all these things, if you learn now, they are going to help you big time when you get to higher classes. So that is the benefit of learning from me today. All right. And then we cover the syllabus, and then it is not just syllabus covering at Unacademy that we do. We have regular doubt clearing sessions, we have live test series, so that before you appear in the exams, you are very well aware of. Okay, Saloni, welcome to my class. Arhan Sabzar, welcome everybody. So just let me real quick tell you guys about Unacademy, and then we will start with our topic today. Okay, so you have this study material, unlimited access to that. We have question answer sessions and mentorship and guidance, because I don't I'm not only teaching you physics, chemistry and biology. I'm going to teach you like how to be successful if you have chosen science as a career. Okay, so if you want to learn with me, please come with me and learn a lot with me. Okay, so here are our ongoing batches. We have full syllabus batch for 2021 already launched. So if you again want to be part of that, go ahead and sign up or register with my code, which is PS13, for extra 10% discount, guys. So okay, yes, we will start. Saksham, give me 2 minutes. Give me 2 minutes. Don't spam with all these questions. Okay, give me 2 minutes. So here are, because many people, they ask me about what are the different charges. Okay, so that is why my class timing. Okay, I'll tell you in a minute. So yes, Saksham, I told you we'll start in a minute. Please let me explain, because people are asking questions about my class timing, and they're asking questions about the subscription cost. So if you can, science is your future, Saloni, definitely, then you are at the right place. I will help you with science. So if you want 1 month, 6 month, and up to 36 months of subscription we have. So it is not even 1,000 rupees per month. Okay, so and on top of all this, you will have this code and to get extra 10% discount. Okay, so now let's get started. And before I start, let me tell you what exactly and how frequently I take classes on Unacademy. Okay, that is also very important. So Monday, Tuesday, Wednesday, Thursday, I take Friday, I take classes at 8:45 p.m. every single day. Okay, you go ahead and search for Dr. Pooja Sharma on Unacademy. Follow me for all the courses that I am launching for all of you. Okay, you can go ahead and sign up for that. Okay, guys, so are we ready? Are we ready to crack this topic today, all about chemical bonding, right? So are we ready? Tell me in the comment section, are we ready to know more about chemical bonds? What are chemical bonds? What are chemical bonds and where do we see them? Okay, what are chemical bonds? Where do we see them? And are they important to us? Tell me. Yes, all of you are ready. So let's get started, guys. I'll make sure like I make each and every point super clear to you when it comes to chemical bonding. Okay, so let's get started. What are they? Where do we find them? Are they really important? So I have this sheet over here where I will write down all the queries, all the questions that you might have. Okay, Anuj, I'm great. Anuj, thank you for asking, and I hope you guys are also doing great. Okay, let's get started, guys. So no more talks. Let's get started. So, chemical bonding. So first of all, let's understand what is chemical bonding. Okay, what do we see around us? What kind of bonds? Why are we going to talk about the bonds? Okay, so we know that there are 118 elements on this earth, right? We know that. Do we all know that we have 118 elements present around us? And all these elements are not in their native states. They are not present in their native states. Apart from few are there, few exceptions are there. Okay, but most of them we don't find them in their native state. So what is native state? Native state means in their elemental form. Okay, what is elemental form? Do you guys know what is elemental form? So elemental form is their original form. For example, if we see iron, gold, it will be present in nature, okay, as gold. Silver most probably will be present in nature as gold, right? Silver. So these are the element, or we have helium, neon, all the noble gases. Argon, krypton, xenon, radon. So all these elements, they are, most of the time we find them in their elemental form. Okay, they don't make bonds. So why is it like some of them they make bonds and some of them they don't make bonds? Why is it so? Okay, why is it so? Let's first understand that. Why some of them make bonds and some of them don't make bonds. For example, if we have oxygen, we find oxygen in nature as O2. Okay, and let's say we have carbon dioxide. We find it as carbon dioxide, CO2. Hydrogen and oxygen, most of the times we find it as H2O. Nitrogen, we find it N2. NaCl, we see NaCl as this. Methane, we find it as this. So that means, okay, so I'm not audible, you're not able to hear me, guys? So that means all the elements, they are always not present in their elemental form. Okay, we see them, they are either bond, they make bond with themselves. Okay, just like oxygen, I'm sorry. So two oxygen atoms are making bonds, okay, or two nitrogen atoms are making bonds, N2, okay. So that means most of the elements that we see, they are having some kind of bonds present. Okay, hello Seth. Carbon dioxide is also having two oxygen atoms, and again there is some kind of bonding present, right? So this is the bonding that I was talking about, and this is the bonding that we are going to discuss today. Why elements make bonds? Can anybody tell me why elements make bonds? Why do they do that? Why cannot they just stay like that? Why do they have to make bonds? Can anybody tell me why elements they make bonds? That is the most important question. You must know that, because we see everything around us in the elemental form, and we must know that why do they make bonds. Okay, so let's start. Okay, Let's start with the simplest one. If we see, to stabilize themselves, somebody answered to stabilize themselves. What do you mean by that? What do you mean by stabilization? Arhar. This is not from any chapter, Saksham. As I said, I'm just picking up random topics to make some concepts clear to you. Oh, awesome, Anuj. Anuj answered it very well. To complete their octet circle or to complete their octet. Okay? So, if we take an example of hydrogen and helium, that is going to be the very basic example that we can take. Okay? Now guys, have you seen hydrogen occur as H2 and helium it occurs as He? Why is it so? To understand that, we will have to first know that what is the atomic number of them. So hydrogen atomic number is 1, helium atomic number is 2. So which means their electronic configuration is 1. In helium their electronic configuration is 2. And what is octet rule? You guys know what is octet rule? I'm really sorry, I cannot write very well here. Let me have a ballpoint pen. What is octet rule? Do you guys know? Every element, it tends to complete its outermost shell. Okay? And how many electrons in that outermost shell it will tend to have? Either 2 or 8. Okay? If the element is having 2 electrons in the outermost shell or 8 electrons in the outermost shell, then we will say the octet is complete. In case of hydrogen, let's draw it. This is the nucleus of hydrogen and here is the shell. Similarly, nucleus for helium and here is the outermost first shell. Okay? So now we see in color, in hydrogen there is only 1 electron present. In helium there are 2 electrons present. Okay? So if there is only 1 electron present, how many electrons will it need to complete its outermost shell? It will need 1 electron. Okay? How many electrons helium needs? Helium does not need any electron. Okay, so that is why when we talk about hydrogen, one hydrogen atom is having 1 electron in the outermost shell. Here is another hydrogen, it has another electron in the outermost shell and they make the bonds. So this is what we call bond because they want to have their outermost shell complete. And helium, it already has 2 electrons and it does not need any kind of bonding. Okay, so that is why we call helium is a, where is my cursor? So that is why we call helium as inert gas. Okay, it does not involve in any kind of bonding. So now with this, so now you have a basic idea like how these bondings they work. Let's move on to different type of bonds that we see in our chemical compounds. Okay, so we will start with ionic bonds, then we will learn a little bit about covalent bonds, what are hydrogen bonds, and then we will also talk a little bit about what are van der Waals bonds or van der Waals interactions or van der Waals forces. Okay, so as we progress, let's get started first of all with ionic bonds. Okay. Saloni, I did not get your question. If you can just explain a little bit, then maybe I'll be able to answer it. So our first type of bonding that we discussed today is ionic bonds. So let's talk about ionic bonds. So guys, there are a couple of points that you have to remember about ionic bonds. That is, number one, ionic bonds are mostly formed between metals and non-metals. Okay, so metals and non-metals, they come together and they make ionic bonds. Okay, second point about them is ionic bonds are very strong bonds. They are kind of strongest bonds which are present. Third, when ionic bonds are formed, it gives rise to charged ions. Could be cation or anion. So we will talk about it. I will explain, Saloni. I will explain. So we will have cations. They have positive charge. Hello, Himanshu. Anions, they have negative charge. So this is the third property of your ionic bonds. 4, they are the conductors of electricity. Okay, and the fifth most important point is they are solids mostly. And sixth important point is they have high melting points. Okay, hello Vrinda, hello Himanshu, Vrinda. So these are the very important points when we talk about ionic bonds. Okay, so what are the important points? They are mostly, the first thing that you have to remember is among ionic bonds is ionic bonds are formed between a metal and a non-metal. Okay, that is the super important point that you have to remember. And second is they are very strong in nature. If they are very strong, that means they have high melting and boiling points, and they lead to formation of cations and anions, means charged particles, positively and negatively charged particles. They are conductors because as they are giving rise to charged particles, that means they are conductors of electricity. They are most of the times they are solid in nature. Okay, so these are the points that you have to remember when we talk about ionic bonds. Okay, now as I said they are Saloni, what didn't you understand? I said ionic, when I talk about ionic bonds, when I show you how the ionic bonds are formed, then I'll tell you, Himanshu, in a minute. So when we talk about like how these ionic bonds are formed, what elements from the periodic table make these ionic bonds, then it will be even clear. The most important point in the ionic bond formation is the metals and the non-metals. They come together to make ionic bonds. So why are we saying so? Why are we saying like metals and non-metals, they make ionic, I'm sorry, M-E-T, metals and non-metals, they make ionic bonds. All right. So guys, here is very important point to understand. So let's first let me delete this and then, or maybe new slide. So we say again it is ionic bonds. So I said ionic bonds are formed between metals and non-metals. Guys, this is going to give you the foundation for these ionic and non-ionic bonds. I'm sorry, metals and non-metals. So how? So metals are present mostly on the extreme left of the periodic table, and non-metals are mostly present on the right hand side of the periodic table. And if we talk about this, the ionic bonds are formed between the most electropositive elements and the element with high electronic affinity. So what are these? So to understand this, let's talk about ionic bonds in sodium and chlorine, guys. So if you talk about sodium and chlorine, sodium is the metal which is present on the left part of the periodic table. Chlorine is present on the right part of the periodic table. Okay, I will show you, Himanshu, in a minute. So with that said, means as I was talking about ionic bonds, I said cations and anions are formed in an ionic bond. Okay, we see cations and anions. So cations will be formed if electrons are removed. If electrons are removed, then cations are formed. Anions are formed if electrons are added. Then anions are formed. Okay. Himanshu, yes, it is formed between metals and non-metals. Now, as I said this, so let's take a quick example. Okay. All right, not yet. So let me add a slide here, maybe. Wait a second. Hold on, guys. Let me add a couple of more slides here. Okay. Now let me explain. Now let's see how bonding between sodium chloride is made. So we know that atomic number for sodium is 11. Atomic number for chlorine is 17. Okay. So we have these atomic numbers. And if we write the electronic configuration for sodium is 2, 8 and 1. And if we write the electronic configuration for chlorine, it will be 2, 8 and 7, guys. Himanshu, I go live at 8:45 on Unacademy's platform. Okay. So 8:45 is my time on Unacademy every day. So if you want to learn from me, you have to sign up and you have to, take my classes, and I teach excellent. That is what my students, they say. So now let's talk about the ionic bond formed between sodium and chloride. As we know, sodium is a metal and chlorine is a non-metal. And I said initially, ionic bonds are mostly formed between metals and non-metals. Okay. So now we know the electronic configuration, atomic number of sodium is 11, electronic configuration is 281. And I don't know whether you have a plus subscription or not, Anuj. That's why maybe. And for chlorine, it is 2, 8 and 7. And now guys, now if we talk about, let's say we want to have complete octet for this, there are two options. If we say we have sodium here, okay, and this is the nucleus for sodium, and here is shell 1, shell number 2 and shell number 3 for sodium, and here we have chlorine. Here is the nucleus. Now here are the shells for chlorine. Okay. So now let's see how the electrons are arranged for sodium and for chlorine. So here we have 2 electrons. Electronic configuration is 2, 8, 1. Electronic configuration 2, 8 and 7. All these bondings are because of the electronic configuration only. Okay. 2 electrons. Now we have 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8, and here is present 1 electron. Similarly, if we talk about the electronic configuration for chlorine, I'm sorry. So we have 2, 8, 1, 2, 3, 4, 5, 6, 7 and 8 and 7. 1, 2, 3, 4, 5, 6 and 7. So guys, now what you have to understand is to complete its octet, it will either need 7 electrons or it will give its 1 electron. Okay. So which option will it go for? This is quite difficult because it is very difficult for sodium to gain 7 electrons, and it is very easy for sodium to give away this 1 electron. So then this 1 electron will be donated. So if it donates 1 electron, it will become, the configuration will become 2 and 8, which is the octet rule, and it will be stable. And now if we talk about chlorine, it has, where is my cursor? Now chlorine, either to complete its octet, either it will gain 1 electron or it will donate 7 electrons. But it will be very difficult for it to donate 7 electrons. So what will it do? The electron which is being donated by sodium, it will gain that electron. Okay. So the electron which was donated by sodium, it will gain that electron. So here we see, okay, so that electron which was given, here is that extra electron. Now it has 2, 8 and 8 octet is complete and it will be stable, right? Because its octet is complete now. So as its octet is complete and it's stable, now let's see. This one, sodium had 11 electrons, 11 protons, and it was neutral. But after donating 1 electron it donated, it has 10 electrons and 11 protons are still there. So it will have, because there is 1 extra proton, it will have 1 positive charge. Okay, it will have 1 positive charge. And because similarly this thing had initially 17 electrons and 17 protons were there, it was kind of neutral. But once it gained 1 electron, it became 18 electrons and 17 protons. So it has 1 extra charge. So it will be negative charge. And sodium will be, where is my cursor? I cannot see my cursor, guys. Okay, over here. So is it clear to all of you? So it becomes 1 positive charge, it becomes 1 negative charge. Okay, so this is what we call ionic bonds, which are made by donating and donating, because sodium donated and it gaining electrons. Sodium donated and chlorine gained. As sodium donated, sodium became sodium plus, chlorine gained, chlorine became chlorine negative. And that is what I said. That is what I said initially. Like in ionic compounds, the charge, there will be some charge on the elements. So sodium is plus, chlorine is negative, right? So this is all about your ionic bonds. Okay, now let's quickly talk about next category. I am so sorry. So I will just erase all this maybe. I don't know whether it will get erased or not. Or maybe I will add another slide over here. Let me add slides here. Is it clear, guys? Are you well aware of ionic compounds now? Hold on. So now let me add a couple of more slides for you, and then we will talk about, more bonding. So now here we will talk about covalent bonds. These are the second type of bonds. So previously we discussed we have ionic bonds which are formed by donating and gaining electrons. But in this case, in case of covalent bonds, electrons are not donated or gained, they are shared. Nobody is ready to gain or donate electrons. They will say, okay, no, we are not into this kind of gaining or losing. We will share our electrons. Now let's take a couple of examples. If we talk about all the elemental forms like oxygen, nitrogen, right? So let's say what is the electronic number, atomic number for oxygen? It's 8. Okay. Electronic configuration is 2 and 6. Similarly, nitrogen is 7. And its electronic configuration is 2 and 5. So let's first talk about oxygen. So one oxygen is having 6 electrons in the outermost shell. How many electrons it needs to complete its octet? 2 electrons. So what will oxygen do? There is oxygen atom number 1. It has 6 electrons. 1, 2, 3, 4, 5 and 6. There is another oxygen atom with same thing. 1, 2, 3, 4, 5 and 6. Right? So what will these oxygen atoms do? They will say, oh, no problem. We are running only short of 2 electrons. So we will make these bonds. Okay. So that is why these two bonds, this one and this one, is made by oxygen by sharing electrons. Okay, so that is why we write oxygen as double bond. Okay, so this is covalent bond by sharing of electrons. Now if we talk about, quickly we'll talk about, nitrogen. So we have one nitrogen atom over here, 5 electrons in the outermost shell. Right, these are 5 electrons in the outermost shell. Here is another nitrogen, similar 5 electrons in the outermost shell. How many electrons it needs? 3 electrons to complete this octet, to make it to 8. Okay, so what it will do, it will share these electrons. Okay, Anuj, I will explain it again, don't worry. So here nitrogen will make triple bonds. Guys, मेरा cursor घूम जाता है बहुत जल्दी over here. Right? So these kind of sharing is what we call covalent bonds. The best example of covalent bonds is, so these were the elemental forms that I discussed, okay? But now I will talk about the compounds. So let me take an example of, hello Alicia. Best example is carbon. Carbon makes multiple compounds due to its couple of properties. One is catenation, second is tetravalency, and third is its small size. This I have covered in carbon and its compounds chapter. I will not get into the details of this, but I will say why carbon is so versatile, and that is a very important question that you get in your exams. Okay, so carbon atomic number is 6, electronic configuration is 2 and 4. So we have carbon over here, 4 electrons, 1, 2, 3 and 4. Now carbon either can gain 4 electrons, okay. Himanshu, catenation is the property of carbon by which carbon makes bonds with itself. Like if you see hydrocarbons, you will see hydrocarbons, long chains of carbons, you will see branched chains of carbon. So this is what we call, you can see closed rings of carbon. So this is what we call catenation. The self-linking property of carbon is called catenation. Okay. Covalent bonds, I will talk about the properties in a minute, but let's first understand how they are formed. So either carbon will have to finish its or complete its this octet to 8. Okay, every element wants to complete its octet. Versatile means so many compounds, so many different type of compounds. So either it can gain 4 electrons or it can donate 4 electrons. Okay, so these are both the options that carbon has, because it has 4 electrons in its outermost shell. Either it can gain 4 electrons or it can donate 4 electrons. But guys, it is not easy for carbon to gain or to donate electrons. Why? Because, okay, if I go into a little bit more details, this is the nucleus of carbon. Shell number 1, shell number 2, and if we see, there are 2 electrons and there are 4 electrons, 1, 2, 3 and 4. Okay, and there is positive charge like protons. How many protons and neutrons are present? 4 protons and 4 neutrons are present in the nucleus. Okay, now let's say carbon tries to gain 4 electrons. Okay, now protons and neutrons are not changing, because in a bonding always electrons are the ones which participate. Protons and neutrons, they don't change, they will remain same only. So now let's say we assume like carbon will gain 4 electrons. So do you think this 4 plus charge in the nucleus will be able to handle 4 negative charge? Not at all. This will be very unstable. Okay, so carbon cannot take 4 electrons. And now let's say we say, okay, carbon can donate 4 electrons. We say carbon can donate its 4 electrons. But when that happens, this 4 positive charge is so strong, it will be acting on, I'm sorry, not 10 electrons. I'm sorry, 6 electrons. Yes, 10. 6 plus 4, 10. I'm so sorry, guys. I got a little confused. So if we are saying it is going to give all these 4 electrons, so this 6 guys, I'm really sorry. It is 6 protons and 6 neutrons. I don't know where my brain was. I'm sorry. Because the atomic number is 6, so it will have 6 protons and 6 neutrons. I'm so sorry about that. Okay. So the 6 proton and 6 neutron present in the center, okay, that will not be able to let all the electrons go, because due to the small size, the nucleus is binding the electrons with a greater force. Okay, so donating 4 electron is not possible for carbon, and gaining 4 electron is not possible for the carbon atom. So what is the option left? What is the option for carbon then? Carbon will say, I will not give my electrons, I will not take any electrons, I will only share my electrons. Okay, 6 protons and 6 neutrons, Himanshu. I'm sorry, because I got a little confused. I just saw this number 4 over here. So whatever the atomic number is, it's 6 atomic number, so it will have 6 electrons, 6 protons and 6 neutrons. Okay, so what will carbon do? Carbon will be participating, carbon will be sharing its 4 electrons. With what? It is going to share its 4 electrons with either other carbon atoms, or the easiest one is hydrogen atoms. That's why in chemistry we read a lot about hydrocarbons, because carbon and hydrogen, they make bonds together. So there is one hydrogen, there is another hydrogen, third hydrogen and fourth hydrogen. So carbon will make 4 bonds with hydrogen, and you see these 8 electrons are shared with carbon and these 2 electrons are shared with hydrogen. Okay, so this is common property. It is not like carbon is the owner of these 8 electrons or hydrogen is there. They will make bonds like this. Okay, so these type of bonds are called covalent bonds, which are formed by sharing of electrons. And if we talk about the properties of covalent bonds, one, they mostly are made between non-metals. Okay, we have seen that carbon is a non-metal, hydrogen is a non-metal, and they are making these kind of bonds. They do not lose and do not gain electrons. They share electrons in covalent bond. Okay, it is by sharing of electrons. Third is they are comparatively weaker bonds, covalent bonds, as compared to ionic bonds. Then covalent bonds, they mostly occur in the gaseous state or liquid state. Just like ionic bonds, they were having most of the times solid state. This topic is not from that chapter. I'm just covering it, just the basic one, And they have comparatively low melting point and boiling points as compared to ionic bonds. They are not conductor of electricity. They do not give rise to cations and anions. They don't give rise to these, right? Because all these covalent bonds are formed by sharing, right? So these are the properties of covalent bonds. Now let's talk about next type of bond, which is hydrogen bonding. Okay, so hydrogen bond, as the name suggests, hydrogen is involved. Okay, for example, let's say in case of water, we have oxygen, and this is oxygen, and we have 2 hydrogen atoms. This is hydrogen and hydrogen. And then we have, let's say, another molecule. So this is hydrogen and this is hydrogen. And it is also bound to an oxygen over here. So this is oxygen, this is oxygen. So when these kind of bonds are formed between hydrogen and oxygen, so this oxygen tend to have a little negative charge. Okay, it tend to have a little negative charge. I showed it with a delta, and this hydrogen is going to have a little positive charge. Similarly over here. So that means because of this little positive charge and little negative charge, there will be some kind of attraction between this oxygen and this hydrogen. Okay, so this kind of attraction between the oxygen and hydrogen is called hydrogen bonding. Kind of these bonds. Himanshu, are you a plus student? So this kind of bonds are like bipolar bonds, and due to this polarity they have a little negative charge and little positive charge, and that is why water molecules, they have this kind of hydrogen bonding. Okay, and now if we talk about van der Waals forces, so that those are the, I will not get into the details. My whole purpose was to make these things clear to you. My whole purpose was to, where is my cursor? Over here. So my whole purpose was to make ionic and covalent bonds clear to you guys. So I guess I have clarified your doubts about how ionic bonds are formed, how covalent bonds are formed, and how hydrogen bonds are formed, and what are their properties, what are different kind of elements which are involved in these kind of bondings. Okay, so now van der Waals forces are between atoms and molecules, and they are the weakest kind of forces that occur in this nature. Okay, and with this I will move on to my quiz. Are you guys ready for this? So let's go over it. So the type of bonding between sodium chloride is, what kind of bonding is there? So we just said sodium and chlorine, they are metallic and non-metallic in nature. Sodium is highly electropositive in nature, chlorine is highly electronegative in nature, it is halogen. So the kind of bonding that they will share is ionic bonding. So most of the times any bonding between metals and non-metals is ionic bonding. Okay. Next question. These compounds have very high boiling and melting points. And as I said when I was talking about the properties of ionic and covalent bonds, then I said ionic bonds, as they are formed by plus and minus particles, they are going to have the strongest bonds. So ionic compounds, they are having very high melting and boiling point. Now, if we go on to this question, and this question says, what is the reason behind the versatile nature of carbon? It is due to which property? Is it catenation? Versatile means why carbon makes many compounds. Whatever we see around us is made up of carbon or its compounds. So why carbon is so versatile? Is it because of catenation? Is it because of small size? Is it because of the tetravalency? And if we get into the details, it's because of all of the above. Okay, carbon can make multiple bonds in the sense with another carbon atom. It can make chains, it can make branches, it can make rings. Okay, so cation is formed, first of all, cation is formed when we have the ionic bonds. Okay, and how are cations formed? Cations are formed after losing electron and has negative charge, losing electron and have positive charge, gaining electron and have negative charge, gaining electron and have positive charge. So we'll say cation is formed by losing electrons, and if something loses electron, the charge becomes positive. So B is the correct option in this case. All right, and then which of the followings are the weakest in nature? So ionic bonds, as I said, they are formed between cations and anions, and they are the strongest bonds. Covalent bonds come next after ionic bonds because they are formed by sharing of electrons. Hydrogen bonds are due to the bipolar nature of water molecules. We see hydrogens getting attracted towards oxygen. Then van der Waals forces, they are the weakest forces that we see in nature between the atoms and molecules. And guys, with this I end today's session. Thank you so much for being present in my lecture. And guys, today at 9 p.m. and at 7:30 p.m. I have two free classes on Unacademy. So if you wish to know more about my teaching style, if you wish to know more about how we work at Unacademy, please be part of these two lectures. So this lecture is mostly, all these are free lectures, so this is kind of a motivational lecture for career counseling, and this lecture is on fitness, the importance of breathing and importance of meditation in students life. Okay, so I hope I will see you guys soon there in my lectures. You guys take care and have a good night. Thank you so much. And guys, class name, I mean, you can find me there, Dr. Pooja Sharma. You can find me there on Unacademy. You can look for my courses, and I guess it is in 10th. I have posted it under class 10. Okay, I teach you guys science, so it will be under science subject. Okay, so with this I end today's session, guys. Thank you so much, and you guys have a wonderful time. Take care and bye bye. Thank you. Thanks. Bye.